Okay, so this is changing the base of a logarithm. I'm just going to show you how it works using that equation there, because we know two ways to solve it. 7 to the power x equals 41. I'm just going to use those two things we've done previous to show how this kind of works. So we know we can rewrite that as x equals log to the base 7 of 41. And then if you've got those cool buttons on our new calculators, we could work that out. Okay, now the other way we've looked at solving that same equation is by taking logs of the both sides. So we'll do exactly the same as we've done before. Log to the base 10 of 7 to the power x equals log to the base 10 of 41. But remember, we could use any base we wanted. It's just in the last lesson we were looking at log to the base 10 because that's useful. Using the power rule, then we get x log 7 equals log to 41. And then if I take the log 7 across the other side, I get x equals log 41 divided by log 7. Okay, so that's the two different ways of solving that same equation. But what I'm more interested in is the fact that log to the base 7 of 41 is obviously the same as log to the base 10 of 41 divided by log to the base 10 of 7. Oh, sorry, that's going to be weird. Let's just move out of the way. So what I want to look at is to compare to see if there's a relationship between log to the base 7 of 41 and log to the base 10 of 41 divided by log to the base 10 of 7. So can you see where the 41 and the 7 are the two statements? And we know, obviously, those two things are equal to each other. So that last example was good, but it wasn't an example of a proof. So that would only, what we did in the previous page would have only worked for those numbers. So we can do exactly the same using letters. And the result we get we can use for any numbers then. So that's what a mathematical proof is. So let's start with log to the base a of x equals m. So the first thing to do is rewrite that as an exponential function, remember. So that's a to the power m is equal to x. That's what we were doing in the first exercise. So a to the power m is equal to x. And we're going to pretend we're just solving that equation by taking logs to both sides. So we can take log of a to the power m equals log of x. Now I want to prove this for any base, so not just log to the base of 10. So all we're going to do is whack a b in there, and that b is going to represent any base that we want. Okay, so again, like we did before, bring the m down using the power rule. So that's m log base of b of a equals log to the base b of x. Okay, and it's just getting a bit messy now, so let's just shrink all that and stick it up at the top there. There we go. So if we just take that log to the base b of a across to the side, we get m is equal to log of base b of x divided by log base b of a. And then because there we have m is equal to that thing, at the start m is also equal to that log to the base a of x. So therefore we can say that log to the base a of x is equal to log base b of x divided by log base b of a. And that's what we call, in logarithms, that's known as the change of base rule. Okay, so there you are. That's what, and also there's an example of a mathematical proof of where that rule comes from as well. Okay, now another useful one we can use as a result of the change of base rule is if we wanted to swap the base and the number around. So if I had log to the base a of b, that is the same as 1 over log to the base b of a. So the base and that number switch. Okay, and that's because if I'm changing it to log to the base of b, so I get an a at the bottom, but on the top I'd have log to the base b of b. Remember, what I'm looking at is what power I'd raise b by to get to b, which would be 1. That's why you've got a 1 in the numerator. So those are two really important log rules for you. Let's do a simple question using that rule then. So say I want to work out log to the base of 8 of 11, okay? And on my calculator, I haven't got that button there, so let's just scribble that out. Let's imagine the only buttons I've got are the log to the base 10 button and the natural logarithm button. Okay, so if I've got an older calculator. So using the change of base rule, I can say log to the base 8 of 11 is equal to log of 11 divided by log of 8, which would give me 1.15 to three significant figures. Okay, now that was an easy question, so let's do a much harder one, and it's going to be a harder equation to solve. Okay, and we're going to use the change of base rule to solve it. So the equation we're going to solve is log to the base 5 of x plus 6 log to the base x of 5 equals 5. You just look at that, that looks awful. Okay, we've got an x in the base, which we're going to have to try to get that out somehow. It's different from the log over on the left hand side. So that looks really nasty. Okay, so the first thing we want to do is we want to get all the logs the same. So we want to change the base of that log to the base of x. So we change log to the base x of 5 to log to the base 5 of 5 over log to the base 5 of x. Okay, and then log to the base 5 of 5 obviously is going to be 1, because 5 to the power 1 gives us 5. So I can change that using the change of base rule into 1 over log to the base 5 of x. So we make that change, our equation should become slightly easier to deal with. So I'd have log to the base 5 of x plus 6 lots of 1 over log to the base 5 of x, which is equal to 5. Okay? And then just type that up again. If we expand that bracket, I'll have log to the base 5 of x plus 6 over log to the base 5 of x equals 5. Now that's still not easy to work with, so we're going to use the same little trick that we used in the last exercise. And that log to the base 5 of x is an awkward thing to be dealing with, so let's just get rid of that and use a substitution. So let y equal log to the base 5 of x. Okay, if you make that change, that equation then, if we make that substitution, that equation should be a little bit easier to work with. Okay, let's just move things around to give us a bit more space. So that's going to give me y plus 6 over y equals 5. Just change those log to the base 5 of x terms into y's. And that's much easier to deal with now, it's much easier on your eyes. Okay, so first things first, we want to get rid of that y in the denominator. So if we multiply all the three terms by y, so we get y squared, the first term, plus 6 because the y's cancel, equals 5y. Okay, so see, look, it just comes down to us solving a quadratic again. Okay, so that's going to be y squared minus 5y plus 6 equals 0. So you know, if you feel that you need to practice these things from C1, it's really important that you do, because you're starting to use them a lot now in C2. So just move everything over there on the left to give us a bit more room. So if we factorise that quadratic, then obviously we're going to get y subtract 3 brackets y subtract 2 equals 0, which gives us two values of y equals 3 and y equals 2. Okay. Remember now though, that's not the equation solved, that's our easy equation solved, which we changed our harder equation into. Because remember, those y's are representing that log to the base 5 of x. So therefore our equation now becomes, our answers, our solutions become, log to the base 5 of x is equal to 3, is 1. Let's just move that up out of the way. Okay. And there you go. There you go. Still fiddling about with it. And the other one, we've got log to the base 5 of x is equal to 2. So instead of y equals 3 and y equals 2, we've got log to the base 5 of x equals 3 and log to the base 5 of x equals 2. Okay, and this is dead easy to solve. If we just rewrite that as an exponential statement, remember that 5 to the power 3 is going to be equal to x. So that gives us, let's just move that, doesn't really run out of room. So that gives us x is equal to 125. So the end bit is actually dead easy. Okay, and then the next one, log to the base 5 of x equals 2. Well, that's rewritten as an exponential. It's going to be 5 squared equals x. So therefore x is going to be equal to 25. And that's it. Let's just put up this so it looks nice and neat. So the answers to that equation were x equals 25 and x equals 125. Okay, just stick it over there. So again, easy. Okay.